Hi, welcome to Shiko SAT Review Series. And in this video, we're going to cover a very important topic, and it is quadratic functions. So in the quadratic functions, there are a few things are very important related to the quadratic functions. So the first, we're going to take a look at the meaning. We focus how to find the roots of zero, how do we change it to a vertex form, and also we're going to discuss how to use a discriminator to determine the numbers of the real solutions here. So before we are even look at the worksheets, I'd like to give you a brief lesson about the quadratic functions here, all right? And so there's some very key, like the features we need to remember here. So let me go ahead and start. And so let's see here. Okay, so for the quadratic functions here, right? Okay, so the first things here, let's say, so the quadratic function. Okay, so the first things here, we want to know the function definition. So what is the quadratic function? So the quadratic function is defined like y equal to f of x, and this is the ax squared plus bx plus c. So it's very important. So here, this is the square. That means your x squared term has to exist before you can define that as a quadratic function. You don't have to have an x term or don't have constants. So like, for example, those are the quadratic functions here. So if you have y equal to the 3x squared minus 2x plus 1, this is a quadratic function. Or if you have it's a 4x squared plus 5x, this is a quadratic function. Or you have like the, if you have the 2x squared minus 1, this is a quadratic function. Or even you have just like the 7x squared. So this is a quadratic function. So as long as the square term exists, this is, we call this a quadratic function, right? So that's the function. So this is the first things here we talk about is a function definition. Then the next things here, we want to know what is the graph of the function, right? So the graph of the function, so if this is a quadratic, then the graph of the function is a parabola, right? Okay, so the graph of the quadratic, the graph is a parabola. Okay, so that means the parabola, you can go like this, like a going down type of the parabola, or you can go up the parabolas here, right? So now this is going to get to the next things. So this is the graph of the function. Okay, so the next things here, it will be this few important constant. So the first important constant here is this constant A, right? So this is the constant in front of the x squared. So this constant A, so this play a very important role. So this constant A, the A can have different values, right? So if A is a positive number, then I know my parabola going to go open upward. That means this is going to be my parabola's look, so it's open upward, right? So the same way, if the A is negative, then I know my parabola is going to open downward. So when you see a problem, immediately you can try to eliminate the answer, which is not correct, right? So if let's say which graph is this parabola, if this is 3x squared plus 2x minus 1, so you immediately know this parabola going to do what? Going to open downward here, all right? So this is the first things here, we need to be careful here, right? So this is the parabola. So this is the first constant, right? So we need to worry about that. Okay, and then the next constant here, we have this constant C, right? So the next one is this constant, is the constant C. So what is the constant C? So the constant C is equal to what? The constant C is equal to, we call this the y-intercept. Right, so why is y-intercept? Because y is equal to the ax squared plus bx plus c, right? So when the x is equal to 0, then we find the y-intercept, right? So when the x equal to 0, so that's why y-intercept is equal to c. So this is c is the y-intercept here. So also like based on this information, you can get a very, the very quick to identify the graphs here, right? And then the next things here, so this is this constant, it's kind of important, right? So it's a constant C. Then the next things here, this is really very important, is that the next topic is how to find the zeros, or some people call it the roots, right, of the quadratic. So we have a three, so you have like two different ways you can find it. So the one in here, you can say, hey, I'm using the factor. Okay, so you can set it to factor, then set each one equal to 0, and then to see, what is the value, right? So for examples here, so if I want to find where is the roots for, let's do a simple one, like x squared plus x minus 2, right? So for this ones here, if I say I want to find 0, so what do we say here? We say, hey, you can factor. So this one will be x plus 2, x minus 1. Then you set this equal to 0. So then you set each one. So like you set this one equal to 0, then you set this one equal to 0, then you solve it, right? So then that's why you know the root is at x equal to -2 and x equal to 1 here. So when we talk about how to find the 0, what's that mean? That really means is, the quadratic, right? So that means if here you have a quadratic functions here, right? So it will go downward. For example, this is go downward. So what is the root of 0? That means here, right? So this is one of the roots. This is another one of the roots, right? That's why you can set it equal to 0, then you try to find each one of them here, okay? So the next ones here, the next methods here, sometimes you say, hey, I cannot factor, then the next method here we say is you use a quadratic formula. Okay, so the quadratic formula, that means you can find it. So how do I find the quadratic formula? So I say x is equal to 2a negative b plus minus b squared minus 4ac here, right? So you have the constants a, b, c. So you can use the quadratic formula to find the, the 0 over roots also. Okay, so those are the few things is very important. And then the next thing is, how do you change, so how do you change we call this vertex form. So what is the vertex form? That means if y is equal to the ax squared plus bx plus c, right? So the vertex form will change to like this. So this is x minus h and plus k. Okay, x minus h and so the vertex here, which will be h and the k here. So a few things for this vertex form, be very careful, right? So here has to be minus h, and here has to be plus k. So if you have a -1, then here will be minus. So this is call this a vertex. So what is the vertex? Vertex is where this parabola changes here. So if you have parabola go like this, right? So then this is the point. So this is the point, right? So this is, we call this a vertex. Okay, so how to change from y equal to the x squared plus bx plus c to the vertex form? So from here to here, the method you need to use, we call this a completed square. Okay, and then we will be able to, we're going to practice some of those completed square technique, so you will know how to change it to the vertex form. So after you change it to the vertex form, so you know here is the vertex, right? So it's the place is changed because of the vertex, right? So also if you draw a line, right? So this lines here, we call it the line of the symmetrics because it is, the graph is kind of symmetric to these lines, right? So these lines here is x equal to what? X equal to h, right? So this is the line of the symmetrics, right? So that's the means the graph is symmetric to that. Okay. Now the last things we want to know is the discriminator. So what is a discriminator? Okay, so the discriminant is what we say is b squared minus 4ac, right? So you do remember, right, just from the previous page, the quadratic formula tell you x equal to 2a, then minus b plus minus square root of the b squared minus 4ac. So you know the 4ac, right? This number is inside the square roots. So in here, so let's tell you, if they say, hey, this is 1, the v is greater than 0, that means I'm going to have to find the 2 real roots. That means your quadratic function will either go like this, touch the x-axis twice, or, either go into upward, depends on your a, so, but it will touch the x-axis twice. Okay, so like in here is a b squared minus 4ac equal to 0. So you will find what we call the repeat roots, right? So you can only find one solution here. So the one solution, that means in here, that your parabola go in here. So it's just touch the x-axis, or your parabola will go like this. It is there, just touch the x-axis. So this is the one. So they have one solution, but this one is double roots, right? Because you have like the quadratic is x squared, so you should have 2 roots. So if this one touch here, we call this a double roots here. Then the other ones here is b squared minus 4ac is less than 0. So the square roots, you cannot less than 0. So in here we say there's no real roots. Okay, so there's no real roots, but this can be imaginary roots. That's what is that value of i's, right? So that's why we say there's no real solutions. So that means no real roots. That means there's no solutions here. Okay, I know this is a lot of summary about the quadratic. So I hope that every time when you try to work on the work problem, the worksheets, if you have trouble, then always refer back to here, try to review again what is those very, very important summaries here, all right? Okay, so let's go to a worksheet and take a look here. All right, so let's, I'm going to the, okay, so here is the worksheets here. Okay, let's take a look at the first ones here. So they tell you, right? So here they tell you these ones here. So the graph y equal to 2x squared plus 10x plus 12 is showing if a graph is crossing the y-axis at 0k. Oh, so graph across here. Now what is the value of k's here? So like in here, because this is a graph touch the y-axis. So what do we say is this here? we say this is the what? This is the y-intercept, right? So which constant is the y-intercept? As our review, hey, here, this is the y-intercept, because when x equal to 0, that's the y's, right? So that's what when x equal to 0 is 0 plus 0 is 12, right? So what is the k values here? K value is what? It's 12. So what is the answer? The answer is these, right? Okay, so it's a first problem is pretty easy here, okay? Okay, so now, so the number 2 here, they say, if xy, the graph of the function, has 2 x-intercept. So what is the distance between this x-intercept? So what is the x-intercept we talked before? So the x-intercept, right? So is where your parabola touch the x-axis here. So this is the x-axis, right? So this is the x-axis. That's what is called is x-intercept, because it's touched the x-axis. And also, this is what we call here. We also call those are what? Zeros, or what do we call here? Roots, right? Okay, so we talk about, we said, hey, how do we find the zero? How do we find the roots here? Right, so that means in here your f of x, right? So the x squared plus 5x plus 4. So when they touch the x-axis, that means y equal to 0, right? So you set this equation x squared plus 5x plus 4 equal to 0. So remember, we have 2 ways to do it, right? The first way is you can factor to see you'll be able to factor or not. So I say, okay, here, I can do this is x plus 1, this is x plus 4. Yeah, I can factor. Then after factor, you set this one equal to 0, you set this one equal to 0 to solve it. So x plus 1 equal to 0. So what is x? X equal to negative 1, right? Then x plus 4 equal to 0. What is x? X equal to the negative 4. And then here, it's kind of like a tricky, so they ask you the distance, right? So the distance, so this is 1 is negative 4, 1 is negative 1. So what is the distance here? The distance is 3, right? So the answer is what? It's C here. All right. Okay, so now next one's here. Let's see here. So this one's here. Y equal to the negative x minus 3 squared plus a here. In the equation above, a is a constant. Oh, then they tell you here, they say, hey, the graph of there is a parabola. So which is true about it? So the first thing here, you say, oh, this is the what is vertex form, right? And I have one very thing, so this one is negative. So we immediately know, so that if it's negative here, right? So it's negative, that means what is going up or going down? So this parabola is going to open what? Open downward, right? All right, so it's open downward. And then because this is the vertex form, right? So this is a vertex form. So what is the vertex here? So the vertex here going to be what? Right? So we're going to be, because here is a minus, I would say it's important. Here it has to be plus, right? So what is the vertex here? Will be 3 and the what? 3 and the 8. Okay? Okay, so that means, okay, so that means here, you're going to have a 3 and the 8, right? So that means your graph is open downward, so something like here. So this is the vertex. So this is 3 and 8. Because it's open downward, so I'm going to have a maximum, correct? Okay, so I know it cannot be minimum, right? So this one cannot be minimum. This cannot be minimum. So it has to be maximum. So the maximas here happen in where the vertex is here. what? 3 and 8, right? So be careful. So it's 3. So if this is a plus 3, then it would be a negative 3. Okay, so this for this problem, the College Board want to test your understanding about the vertex form. All right? Okay, so now let's take a look, right? So they say the number 4 here, they say, if a y equal to the 3x squared plus 6 plus 2 is a graph in the xy plane, which of the following character of the graph is displayed as a constant or coefficient in the equations? So basically, this kind of is a little bit difficult to read, but it's telling you, hey, you know, in this graphs here, you know, the displays as a constant. So this is a constant, right? So displays as a constant. What that means? Well, from our review, what is that means? This is what? This is x. What is here? This is y-intercept. Correct? All right, so this is our answers here. Okay, so let's take a look at number 5 here. All right, so they say in the xy plane, a line has the equation y equal to c, all right? And for some constant c, intersect a parabola exactly at 1 point. Wow, this one, okay, so let's highlight. So this line exactly at 1 point. So if the parabola have the equation negative x squared plus 5x here, all right? So then what is the value of c here? Okay, so this one, in fact, I think is kind of a little harder problems for these sections here. So basically it's to tell you, okay, so let's take a look at what that means here. Okay, so I have lines here, right? So this is my line. This is y equal to c, all right? And then I have a parabola. So this parabolas here, look here, you know, the coefficients here, this is negative, right? So I know this parabola is what? This parabola is open downward, right? And then it only accept this one at 1 point. That means that I know my parabola has to go like this. Well, has to, then this point they intersect has to be what? Has to be vertex. Correct? Right? So this has to be vertex form, right? Because that's why that's the only point, or for any other point, you're going to intersect this line at 2 points, correct? Okay, so now I'm going to see how I'm going to do, you know, find that. So this is y equal to negative x squared plus 5x. So I need to change this to the vertex form. So let's put the negative sign out here. So this is x squared minus 5x. So like during the review, we say you need to use the completed squares, right? So I hope you still understand. Remember what is a completed square. So what you need to do is here. Okay, so this is the middle, right? So this is a 5. So you need to divide it by half. So what is that? It's a 5 over 2. So then you need to add a 5 over 2 to the square. Okay, and in here you said you add a 5 over 2. Now you have a negative sign. So basically you're minus 5 over 2 square. So you cannot just add or subtract. So you need to add it back. That's what we mean the completed squares, right? So you add it back here. Okay, so now these ones here can turn into, this is x squared minus 5x plus 25 over 4, right? Then here plus 25 over 4. So what is this one? This is the completed square, right? So here, okay, so that's what is in here. So this one's here will be x minus what? 5 over what? 5 over 2. The whole thing square plus 25/4. All right, so this is the vertex form right now. So based on this vertex form, so what is my vertex here? The vertex will be 5/2 and 25/4, right? So the C is the height, so it's y coordinate. So that's why I know the C is equal to the 25/4. Okay, so this one is a little harder and the other problems here. Okay, let's take a look at a few more problems, and then maybe we can stop at the video so we don't overwhelm it, last too long. Okay, so now in here, this one's here said f of x equal to x plus 3x minus k. The function is defined above. K is a positive number. Okay, k is a positive number. Then which of the following is the graph? Okay, so the first thing is here. I know the x squared if you FOILed it. So what here will be x squared. So the constant in the front is what? It's a positive. Correct? So if it's a positive, so I know my graph has to be open upward. So far so good, right? So I have to be open upward. So what I do here, so I know this one cannot be, this one cannot be. All right, so now I also next see where they intersect at the x-axis. So remember we said the x-axis, you set each one equal to 0. So you will set x plus 3 equal to 0, x minus k equal to 0. So x equal to -3 and x equal to k. We don't know what is the k, but then we know that one of the x has to be -3. So which one is -3? Here, right? So that's why we know these ones will be the answers here, okay? So that's how do you look at it and find it. Okay, so now the number 7 is here. The number 7 is x squared plus x minus 12. So we say, hey, this is a quadratic, this is the solution, okay, of the equation. So what is the value of the a's here? Oh, how do I find the solution of a quadratic? First one, so let's factor to see we'll be able to factor. So I know x squared plus x minus 12, I can factor to what? X plus 4 and what? X minus what? X minus 3 equal to 0, right? So I set first one equal to 0, second one equal to 0. So x equal to -4, x equal to 3. And they tell me a has to be greater than 0. So what is the value of the a? A has to be equal to 3. So far, so good? Okay. Okay, let's take a look. Number 8 here. So number 8, it tell you f of x is equal to 5x squared minus 3. Fx plus a is 5x squared plus 30x plus 42. So what is the value of a? So in this problem, they try to test you is what is f of x plus a means. All right, that means, you replace every x here with x plus a. Okay, so let's take a look. This is x plus a. So that means you replace everything. This is x plus a to the square minus 3, correct? Okay, so for your that, so x plus a squared, so it's x squared plus 2ax plus a squared minus 3. So you will have 5x squared plus 10ax plus 5a squared minus 3. Okay, then it says this one is equal to the 5x squared plus 30x plus 42. So we know the similar term has to be equal, right? So I see here, so I say, oh, this is x term. So 10a has to equal to what? So 10a has to equal to 30. So what is my a here? A is equal to 3, that's right? Okay, so that is how to, so basically these ones here want to test you, how to, what is x plus a mean? That means you need to replace back to your original function and every x to the x plus a. All right. Okay, so let's take a look at the next one. Okay, number 9 is here. So, okay, so the number 9 tell you the graph of the function f in the xy plane above is a parabola. So that means it's a quadratic function. Which of the following defines the f? Okay, so let's take a look here. Because this is opening up, right? So because this is opening up, and so the front constants has to be positive. Every one of them is a positive, so that's good. Okay, so now in here, this is my vertex here, correct? Okay, so if I change it to the vertex form, so my y has to be something, and it's x minus 3, x minus h plus k, right? And plus 1 here. So it has to be something like this, correct? So it's x minus 3. So cannot be x plus 3. So b is not, right? Then the d, okay, so it's x minus 3. So d is not. So the possible answer could be A and C is here. So how do I know which one is which? We said, okay, let's, we can, you see here, those are the points laying on, it's lines on the graph, right? So we say, hey, let's see which one satisfies it, right? So now if I try, okay, so now let's try C. Let's see here, try C's here, right? So f of x equal to the x minus 3 plus 1. Let's see if this one work or not. Okay, so let's try 2, 5, right? So that means 2, 5. That means x equal to 2, right? Y equal to 5. Okay, so you put here, so it's 5, y equal to 5 is equal to 2 minus 1, 2 minus 3, sorry. So it's 2 minus 3, 2 minus 3 the square plus 1. So this is 2, or this is 2, right? So I know what? I know 5 is not equal to 2. So this equation cannot be true. So it's C cannot be true. So if you don't believe, let's try to see A is here is true or not. So A is f of x is equal to 4x minus 3 squared plus 1. Okay, let's plug in the 5, 2. So 5 is equal to the 4 times 2 minus 3 squared plus 1. So this is 4 plus 1 equal to 5. So we know 5 and 5 equal to 5, right? So that's correct. So this one is correct here. Okay, so now the next one's here, and I think we will stop this video after we're doing the 10 problems here. Okay, so the number 10 tell you the range of the polynomial function is a set of a real number less than equal to 4. Okay, so key things here is less than equal to 4. The 0, oh wow, those are keywords. If the 0 of the f is negative 3 and 1, which of the following is the function? Okay, it's less than equal to 4, right? So let's take a look at the graph here. That means it has to be less than equal to 4 here. Okay, so I know immediately this one cannot be the answer. This one cannot be the answer because this one's answer is greater than. So this one's here, the range is here is what? It's greater than equal to negative 4, right? It's not true. This one's range is here is what? Is the whole real number, right? So this one is not true. Okay, so both here and here, right? So this one is less than 4, this is less than 4. So could it be A or could it be B? So let's see here. Now the 0 is negative 3 and 1. That means I have to touch the x-axis at x equal to negative 3 and 1. So which one here? Ah, this one is negative 3 and this is 1. Right? So the answer So what is the answers here? The answer is A here. As you can see, the B here, this is -1 and 3, so it's not the 0. 0 is -3 and 1, so it's A. All right. So so this is a long video, and we will stop here, and we will come back on the second video to finish this worksheet. All right. Okay. So nice to talk to you, and make sure to go back to review what we did for the quadratic, and so make sure you kind of remember all the key features about the quadratic function. All right, that's it, and have a good day, and I'm so looking forward to talk to you and in our next video so we can finish this worksheet. Okay, bye.